Hello everyone, this is a video lecture for Calculus 1, section 2.6, Limits at Infinity. I'm just going to jump right in to 6003. So I have this really gnarly graph, and I will try very hard to make it good looking, and I will be failing very, very quickly. But here we go. So I've got this graph that comes down, and then it comes back up here. And then at 1, there's a vertical asymptote. It goes like that. On the other side, at 3, it kind of comes down. It crosses through right around here. It goes down, so that's a vertical asymptote as well. There's a horizontal asymptote right here at 2. And also at -2, apparently, because there's another graph that does this, and then it kind of levels off. Okay. Wow. So they got a whole list of questions here. It says, part A, limit as x goes to infinity of f of x. So as we go towards positive infinity, that's this way. With x, what's going to end up is I want the y value, and you can see it's going to be there at -2. The end. And we're just looking at the graph to get some of these answers. The limit as x goes to -infinity of f of x. -infinity, that's this way. What's its height? It's +2. Part C, the limit as x goes to 1. And so notice it just 1. At 1, they're both going up. So that's going to be a positive infinity. Part D, the limit as x goes to 3, that's 3 right here, of f of x. Where are the y values going? Well, this one's going down, this one's going down, so they're both going the same direction, -infinity. Part E, they say, where are the asymptotes? Where are the asymptotes? So I got x equals and stuff, and I got y equals and stuff. And you're just going to put some numbers in there. It is very easy. So for my x values, you can see I got it here at 1 and at 3, so 1 and 3. And then y values are here at +2, -2. The end. That was it. So we did this back in college algebra. There's nothing really new to it. I'm not going to assume you remember everything from college algebra, but I'm just looking at y values. All these right here, they're just y values, given that I have an x value. Okay, that's it. Graphically, not too big of a deal. I'm not going to do much more with that. Okay, so now we're going to get up to these problems where they are going to be limits with infinities. I'm going to demonstrate this one. So we got limit as x goes to infinity of 4x, make that a little bit better looking, 4x squared minus the 5, all divided by 3x squared plus x minus 3. And they say just figure that thing out. By the time that we are done with this section, I hope that you can just look at it and get me the answer immediately. So I'm going to wait for a second. All right, what's the answer? No, of course not. I'm not going to go down that road yet. What I want to do is I'm going to do the long way, the proper way, the book way, and then after that I'm going to do the Chad way, and that's the quicker way, by the way. So what I want to do is the long way, and this is how this works. I want to be able to plug in the infinity, right? But what would I get eventually is infinity over infinity, and none of that's going to work. You can't really do that. We're going to actually have a lot of content devoted to what do we do with infinity over infinity kind of stuff. But not right now. That's later. Right now what I want to do is just focus on getting these guys done. So the strategy to make this work is that I need to divide the top and the bottom, that's the numerator and denominator, by the highest degree polynomial. Now that's kind of a weird statement, but what I want to do is I want to divide both the top and bottom by x squared. Notice that x squared is the biggest degree, I guess, polynomial. And again, I'm wanting to keep it basic. So when I say polynomial, I really mean it. I just mean the most basic thing you can think of when I'm meaning it. So 4x squared minus 5, all divided by x squared, and then big division, right? And then I got my 3x squared plus the x minus 3, again, all divided by x squared. Both the top and the bottom get the same thing. That way you're not actually changing the problem. You're not doing anything wrong. Okay, so what does that do? Well, each one of these are going to be distributed by this x squared. And so we will end up with a 4 minus 5 over x squared. And then we'll end up with a 3 plus, I guess it's just going to be a 1 over x. Again, right here, x divided by x squared is going to be 1 over x. And then here, a negative 3x squared. So this is all equivalent. There's nothing wrong here. It's all the same. But now plug in your infinities. And what you're going to end up having is 5 over infinity. Here you'll have a 1 over infinity and a 3 over infinity. I mean, again, a lot of math people, a lot of math teachers do not write this step. They don't write it. They just say, we'll apply the limit, and somehow I'm always going to remember. That's okay, I guess. I'm just saying that this is really what's going on in, in reality. And just as a real quick reminder, 1 over infinity is equal to 0. What if I had like a million billion in the bottom, and I said 1 divided by that? Yeah, guess what? Round to 2 decimal places. It's 0. So there you go, 2 decimal places. This is 0. And so that's the idea here. It's a concept, not quite a number. But this is a 0, that's a 0, that's a 0. And so what we're left with, the only numbers, is 4/3. And that's your answer. Now, I want you to kind of look at this whole problem here. Zoom out for a second and tell me if you can just spot the answer without doing any math. I'm waiting. All right, here it is. You see it? Boom. Yeah, it's 4/3. Now, let me tell you why. It's not always like that. It's not so easy every time. But the reasoning behind this is that this here, these are x squared and x squared, and these are the highest powers. I'm going back to my rules for the horizontal asymptotes. And that's basically identical to what we were talking about right here. Horizontal asymptotes, okay? So there's the horizontal asymptotes, and in particular, there's a rule, rule number 2 is what I call it, where the degree of the top and bottom are the same. And so basically what happens is I take the front fraction, that's what I call it at least, the front fraction, and that's what I'm going to do. Take the front fraction, call it a day, and everything else is gone. And I could talk thing for a very long time, much more minutes. I would love to talk about magnitudes of infinity and all kind of stuff, but this is Calculus 1. We're just starting. And so what I'm going to just go back to is horizontal asymptotes. It's something that we've all seen before. And so that was it. You're done. So you can do it the long way, you can do it the easy way. Whatever. So you might be wondering, why do I do it the long way at all? Because some problems are going to be a little weird. And yes, there's always a trick. Yes, of course. But will you remember every trick? Is it possible for me to actually teach every trick and for you to remember those tricks? I mean, think about it. I've been doing this for how many years and had all kind of graduate level classes with limits and blah, blah, blah. And so I know the tricks because I've gone into super higher math about all this. And I will be teaching you tricks. This is a trick. That's fine. And it works. But there's so many out there that there's no way I could just explain it all here in Calculus 1. And so I will do the long way still. But you can already see the answer. Come on, give me the answer. What do you think? It's 7/2. You're done. That was it. Ta-da! I mean, I get it. But let me show you seeing this stuff. Notice that this is degree of 1, right? So what I'm going to do is divide both the top and the bottom by that highest degree polynomial, which is, well, x to the 1. And so what happens here is that I have my x's here cancel, but here, I guess you could say distribute your denominator. You would get 7 minus 2 over x, and over here we get 2 plus 3 over x. When I apply the limit, when I actually plug it in, I get 2 over infinity, I get 3 over infinity, and we've already noted that those go to 0, and so there's your answer. And you can see the long way is not too long if you kind of know what's going on, but the short way is obviously way shorter, but doesn't work every time. So I've got the limit as x goes to infinity of the square root of x plus 5x squared, all divided by 2x minus 1. See? Look at this one. I'll wait for you. Come on, give me the answer. I'll wait. All right, I'm not going to wait. So maybe you see the answer. Maybe. I'm not going to give it to you yet. Let's go through the long way and try to figure this thing out. Now, how am I supposed to divide both the top and bottom by the biggest polynomial something or other? Well, if you notice, the square root's kind of interesting, but notice that we have an x to the 1 down here. So, I mean, that might work. And if you took this square root, and I'm going to do bad math here, what if I just did this? What's the square root of x squared is just x to the 1. And so, ultimately, if you were to kind of conceptually see it, you would see that that's going to end up being just an x in the end. And so what I'm going to do is divide both the top and the bottom by an x, okay? Something kind of like that. And I make, this is just between you and me because we're all math people now. I make really big division signs. When it says big division, boom, I really make it big so I do not get confused. I don't want to come back and have this and like, okay, well, which one was the longest one? Which one was when I was supposed to do this and that? Just really big. That way you can never mess it up, okay? Just little hints and tricks that you learn along the way since you'll be doing math for, a while. That's a terrible 5. Okay, so this is easy down here to do. So I'm going to real quick just do the bottom. I got 2 minus 1 over x. That was easy. But this one here is a little harder because it's like there's a square root and then divided by x. What do I do? What I'm going to do is integrate it inside of the square root as now an x squared. So notice that this x was on the outside, right? I'm trying to make sure you see it's on the outside. But now I've moved it in. See, I messed up. I just messed up. It's an x squared. So I moved it on the inside of the square root as an x squared. And so how is that possible? Well, what if I do the square root to both the top and the bottom? Well, I would get back to this guy. So that's okay. That's a good thing. And so now I can finally distribute denominator on the inside of that square root. And so I've got 1 over x, and then I've got basically here a 5, just a plain old 5. And so now I'm going to apply that limit. I'm going to plug it in. And so I got 1 over infinity. Again, I'm doing some steps that maybe other teachers will not do. I'm comfortable doing this. Some folks just say, oh, well, those are zeros. That's fine, whatever. And so, yeah, those are zeros. So I got square root 5 over 2, and that's your answer, and you're done, okay? Cool. So let's go back up to the top and see, could you have gotten that by just looking at it? Is it possible? And yes, it is. This square root right here, it applies to everything, but even that 5, and then you got your 2. There's no square root for the 2, okay? So that's how you can kind of look at it. But in a way, how did I know I was actually going to be doing that in the end? Well, because, and then this is just all conceptual stuff. Let's just say that I have x equals infinity, right? And I'm going to plug that in to these x's here in a minute. And so I don't want to go too conceptual, but I do want to show you what I'm thinking here at least. Let's think of an infinite number. Let's just talk about it, okay? So let's think money. Money's easy thing for all of us to think about. So an infinite amount was something that's so large that it's unimaginable that you could even have that. And so I'm just going to go with $1 billion. you have $1 billion. Not a million, $1 billion, okay? And so I would have $1 billion for X, and I'd have $1 billion here. But now notice that 1 billion squared. 1 billion, not plus 1 billion. No, it's 1 billion times 1 billion. That's like 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And then I'm going to start over again. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That's how many we're talking about. Like, I don't think they can even print that much money in the entire world. It just doesn't exist. This is way too much. And so, in the end, what you have is 1 billion, and then you have 5 times a zillion. Just, I don't know if that's a technical term or not. So, the billion part to a zillionaire, 1 billion is like, you know, pocket change. Whatever. It doesn't mean anything. And so what we ultimately end up with is something kind of like this. But again, that's kind of like infinity squared. Well, I can take this. So I remove the things that are lesser. Well, now I'm going to distribute my square root. And square to square cancels. And of course, in the bottom, we always had the infinity from the x there, the 2x. Cancel your infinities out, and there you go. This all here is very bad math, okay? It's bad math. It's all concept. It's no algebra. Don't do this. But if you understand the concepts, then you can skip your steps. Because what am I doing? I'm actually just doing this. I'm doing this just in my head. Okay? I'm doing all this process just in my head. Okay? Do not do that. I'm not going to promote that. I'm just showing you that there are ways that we can think about this to get answers quickly. But they're not really, I wouldn't always call them reliable. It's always good to do the algebra. It's always good to do the math, okay? Limit as x goes to infinity of the square root of x squared plus 7. And they say, figure this thing out. Okay, well, normally we have a top and a bottom where I can divide stuff out. I don't have that here. I don't have any means of which to change this thing. And so I'm actually just going to plug it in. I mean, there's nothing else for me to do. We've got to plug it in at some point. And yeah, basically we're going to end up with an infinity. And that's it. You're done. That's the answer. That's your answer. There's nothing to do. That was it. Now, how is that your answer? Let's kind of just go through it. I got infinity squared plus 7. Do you really need that plus 7? So you have $1 bazillion, and someone says, hey, man, can I just give you $7 more? And you're like, I don't really care about $7. And so you have this guy, and then square root of square cancels. Now, this is another funny little concept. If you just had infinity squared in the end, the answer is still just going to be infinity. It's just a magnitude thing. You're not ever, in WebAssign, you're not ever going to put infinity squared as an answer. It's never going to happen like that. So just don't. If you have some kind of concept like that, it's just, here, look, square root of infinity. What are you going to put for the answer? You'll just put in infinity. Because, again, infinite amount, you square root it, doesn't matter. It's still huge, infinite. Okay, so that's my answer, but apparently I have in my notes here the official method. Here's the official method. And honestly, I always want to start with the long way first and then the short way. And somehow I just did the short way. Because this official method is not something that I would promote. Not this guy. Nope. Sometimes I promote the long way. Sometimes I say don't do it. I'm going to say don't do this thing. So they're trying to compare different functions. And we're going to be doing this a lot more in Calculus 2 with infinite series and stuff. So we have, this was our original, which is always more than this dude, which actually equals just plain old x. And so if I plug in the infinity, because, you know, x is going to infinity, I would then say I've got the square root of x plus 7 all, x squared plus 7 all square root is still greater than, guess what, infinity. Well, what's a number that's more than infinity? Infinity plus 1! Whatever, it's infinity. That's why if infinity is smaller than this dude, this guy here is definitely infinity. And it's, again, just a concept. I don't really like that so much. It's good enough. We're moving on. So the limit as x goes to negative infinity, be very careful about that. Be very careful because we've been just doing regular old infinities for everything. Now all of a sudden they're doing a negative infinity. All right, now figure it out. So there's two ways to getting this done, of course, probably three. What if I just plug in the infinity? I just want to show you what happens. We're just using algebra in a way here. How many negative signs do you have here? 4. And they all cancel, leaving a regular old positive infinity to the fourth. How many negative signs you got here? Well, actually, you get 7 negative signs. All of them cancel except for 1. So you actually end up with something like that. Well, you have a positive infinity to the fourth is nothing compared to infinity to the 7th power. And so that's going to be very, 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 very big. But notice that it's negative. And so I don't care about the 2. I don't even care about the 7. Negative infinity. There you go. Okay, so that's a concept. In reality, I want to graph this thing. And if you're looking here, what we're going to use is the end behavior. Okay, so we got basically a positive x to the 7th. Notice that I don't care about this guy. Notice I don't care about the 2. And the 7th power, I'm only really using it because it's odd. And so whomper, 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 something like that. But as we're going towards negative infinity, which is like, this way, you can see that it's going down. It's going down. That's your answers, down. So that's end behavior back from college algebra. And again, I'm just using the fact that it's a positive and odd to make that happen. I hope that out of all this, you're seeing that there's multiple ways to see this. I don't want to scare you off. I don't want to say like, oh, well, every problem is different. Because they're not. Every problem is the same. But I'm just trying to show you different ways. Don't get scared off. Don't think, well, I got to remember all these different things. Pick something that works for you. I'm just showing you different ways to do it, okay? Do you like apples? Here's some apples. Do you like some oranges? Here's some oranges. You don't have to eat an apple and an orange every day. You just pick one. You like apples a lot? Eat apples every day. I'm okay with that. Okay. So I got the limit as x goes to infinity of 1 minus e to the x divided by 1 plus 6e to the x. Okay. I'm going to pause. I'm going to wait here. What's the answer? You got it? Do you? Let's see. Let's do it. I'm going to do it the long way. One thing to note, I'm going to put a little note over here, is that I got the limit as x goes to infinity of e to the x is infinity. So if you look at the graph, it'll keep, as you keep going this way, it'll keep going up, right? Infinity. So what I'm going to do is whenever I plug in my infinities, I'm just going to basically have these e's turn into infinities. Okay, that's ultimately what's going to happen here in a second. But I can't do that right now because I'm going to have the infinity over infinity thing, and you can't necessarily technically do that, blah, blah, blah. Can you tell I have a certain way of thinking? So instead, what I'm going to do in this particular problem is divide both the top and the bottom, just like we did last time, by, I guess you could say, the biggest function. And that's going to be my e to the x. And so if I apply that denominator to both of these small numerator things, I get 1 over e to the x, and then minus 1. And then over here I get 1 over e to the x, and then plus the 6. When I apply the limit now, I'm saying that this e to the x is infinity, so that means this guy and this guy actually turn into infinities. But 1 over infinity is 0. So there's my answer. Done. Did you see it? Did you get the right answer? See? You just cancel your e to the x's because that's the most powerful function. It's the one that's going up the most. You cancel them, of course. You don't need that stuff at all. You cancel them, and there you go. Okay. It's hard. It's hard being a good teacher and trying to show all the good teacher things, but at the same time, the answer is just right in front of you. Okay. It says find the asymptotes, and we got y is equal to 4x squared plus x minus 1 all divided by x squared plus x minus 2. All right, so I'm going to find all these asymptotes. Cool. So what they mean is vertical asymptotes and horizontal asymptotes. And vertical asymptotes are, again, when the bottom is equal to 0. So I'm going to set the bottom equal to 0. And so then I think I can factor that. So what two numbers multiply to a 2 but add up to a 1? And I'm going to say it's a positive 2 and a negative 1. Therefore, I get x equals a negative 2 and x equals a positive 1. Cool. And yeah, those are actually going to be your answers here in a second. The horizontal asymptote, singular, is the 3 rules. And so if you go back, I'm going to just rewrite what we have here. 4x squared plus x minus 1, all divided by x squared plus x minus 2. So this is rule number 2. I'm just going to remind you about this stuff here. This is rule number 2. You can see the degree of the top and the bottom are the same. And so I'm going to take the front fraction here, okay? And so my horizontal asymptote is basically just a y equals 4 over 1, which everybody knows is just going to be a 4. Okay, those are your answers, and what they're wanting here, in particular for the x's, is for you to put them both in the same box with a comma. Sorry, that's a positive 1. So this is your answer for part A, that's your answer for part B, and there you go. What I find incredibly silly is that they are talking about horizontal asymptotes, right? Horizontal asymptotes, and front fractions and all that stuff right here, which is basically what I've been doing the entire time. Like as soon as there is one. Here. There it is. There it is. There it is. I mean, we've been doing it the entire time. So now you're wanting to talk about horizontal asymptotes after I've already done all the limits? Fine. Fine. But now you know that the concepts that I'm showing you are actually truth. Okay? They're actually real. Just doing algebra. That's all I'm doing around here. We're not even doing calculus yet. Well, kind of. It's calculus a little bit. Okay. This problem here is got to be the weirdest and the longest, the hardest problem of this section. There are a couple problems where I recommend that you just basically get it wrong 3 or 5 times, whatever it is, and see what they have for their answer so that you can understand what they're getting at. What are you asking for? And I promote this. We're not gaming the system here. I just need to know what you're asking for because I am very confused about all of this. Look, I'm not even done. I'm just still writing all this stuff. Limit, I got x goes to 7 from the right. Okay, we got this guy. And then we're still not done. Okay, there we go. This huge list of stuff here. And supposedly, I'm having to come up with a function. Okay? I could just give you the answer to show you how ridiculous this is from just kind of zooming out. Like, wow, how would I ever know that? I get that. I totally get that. And so if you go to the homework just real quick, and you like if you're doing the homework with me here, go to your homework, this problem, and submit it a couple times right quick and just see what the answer looks like. And you're just going to be like, what is going on? Exactly right. So I want to talk about it, of course. That's why we're doing this problem. I can't just skip it. Okay. The idea is that we're going backwards. We have all of these constraints here, and we're going to find our function. We need to know what is my function, what is my original question in order to get this thing to work. And I'm going to be utilizing the graph concepts as much as I can. Right here. This is a great idea right here. Notice that I'm saying as x goes to negative infinity and positive infinity, that is on a graph, I'm going like to the far extremes out here, my y value is a 0. What this means, what this whole thing right here means, is that I have a horizontal asymptote at y equals 0. Okay, that's what it means. But going in reverse, how do I get that? If you use the 3 rules, it means that the degree of the top is less than the degree of the bottom. That's rule number 1, basically, okay? So in a way here, my point is that we're going to take each piece of information and we're going to extract something that we need to know from it. It's just a piece of the puzzle. And after I have all my little pieces of the puzzle, I'm going to mush them all together, hopefully, and get the right answer, okay? That's my goal here. Okay, let's talk about this guy. So my limit as x goes to 0 is equal to negative infinity. So at 0 is this guy right here, and they're saying it goes to negative infinity. So I have a graph that's going to be going down both there and there, basically, okay? So I have a graph that's going down at 0. Now, on both sides, though. Both sides, right? It has not a plus or a minus. It has both sides. What this looks like to me is a vertical asymptote. A vertical asymptote at x equals 0. Okay? So that's another piece of the puzzle. And again, vertical asymptotes, where's that happening? That's when your bottom is equal to 0. But we're going to see that again here in a minute. Okay, here's another one. Notice that this is only from the left side. And we're talking about 7. So 1, 2, 3, 4, 5, 6, 7. At 7, we're going to positive infinity. Okay? And this one kind of ties in as well because this is a 7, and this is on the right side. And they say that we're going to negative infinity. So that's going to be going down. Again, I have a vertical asymptote at x equals 7. So that's cool. Bottom equals 0, all that kind of stuff. But my problem is that this is a little different. Here, we have them both going down at the same place. Here, they're not. And so there's going to be a little bit of distinction here. There's a distinction. If they're ever going down or up in the same direction, that means it's going to be an even multiplicity. Even multiplicity, okay? That is a old term back from algebra. We don't use it as much anymore. But even multiplicity means they're going the same direction. And that applies to, say, like plain old x squared is a parabola. They're both going up. And so even multiplicities means they're both going the same direction. In this case, they're both going down, okay? Because these are going in opposite directions, this is going to be an odd multiplicity, okay? So there's something else to consider. Now, when I say even and odd, what is the first even number? Let's just start with that. What's the first even number? And I'm going to tell you it's a 2. I put a little m, but really I should probably do mole. So mole 2, multiplicity of 2. What's the first odd number? Be careful. It's actually just 1. Multiplicity of 1. So we're going to use those numbers to help us. And when I say multiplicity, I actually mean the power. I mean the power, the degree, well, I'm going to just call it the power of the factor that makes that happen. Okay? So we're getting pretty close here. Now, this one right here, what is going on here? This is a 0. That's a 0. Well, I guess at x equals 6. This is when the top equals 0. Okay, so that's good. And, well, there you go. So what I'm getting at is this horizontal asymptote is not going to help me much. It's more like a verification, like check, yep, it's going to work. But these guys here are going to be the meat and tater side. So I got a multiplicity of 2 at x equals 0. I have a multiplicity 1 at x equals 7. What would that look like in factored form? And so in the denominator, I've got x minus 0 squared, and I got an x minus 7 to the 1 power. You do not need to put minus 0. I'm just making a point here. Okay, but squared is important. Those are the multiplicity things. In the top, right here, top equals 0, I have this guy. So what's the factor for x equals 6 is x minus 6. And there you go. And what you've actually done is you have completed this problem. You type it in and you get, wrong. What? This is the right answer. Why? That is confusing. Where did that negative come from? Well, everything else came from every other place, but where did that minus come from in particular? I went through this before I started recording, and I wanted to look at it one more time. And it's right here. It's right here, these guys. This makes a negative in the front. And now you might be wondering how that works, but let me give you some demo examples, okay? Here's a demo example. Let's say I have positive 1 over x. What does that graph look like? Well, I go down. I just want to focus on the asymptote, and I'm going up here, okay? But what if I had a negative 1 over x? What does the graph look like? It's going up, and it's going down. This is the configuration that we have. And so therefore, it's that same concept, but we have a negative in the front. And there's where that negative comes in. Ugh, I know, right? So many things to remember. And that's why I recommend on this problem, get it wrong a couple times just to see what the format is and kind of work with it. I mean, you can see that you don't need this 0 thing here. It's not going to randomize much, I guess. You could see that these numbers came from what we were talking about. Okay. It's the best I can do. I definitely wanted to talk about it. I could talk about it all day, but I'm just doing the best I can with what I got. Actually, we got 2 questions. The last one's super small. So this is the second to last question. It says, how large for x? So I'm going to write how large of an x so that we get 1 over the square root of x is less than 0.001. Now that's just kind of like weird. And how they have the box is x greater than box. Okay. So what are we supposed to do? Well, we're going to like solve, I guess. And so what I'm going to do is take this and I'm going to solve it kind of like there's an equal sign there. Now, I think there's one step here in a little bit where we're going to have to be a little careful, but just imagine there's an equal sign. So we're going to solve for x. I'm going to multiply this to the other side. I'm going to divide this over here. So we get 0.001. Okay. And then I'm going to square both sides, right, to get rid of the square root. And what happens is that you get, I'm trying to do this right, a 0.00001, I think. I don't know. I can't remember how many zeros we got. Maybe there's one more 0. I don't have that in my notes. I just kind of said, there's your answer. So square root both sides, or square both sides, and there you go. So x is now greater than technically 1 million. That's going to be my answer, okay? 1 million. Okay. So there you go. There's how you get that. And we're done with it. Except that there's a whole lot of words here in my notes, and I'm guessing that what's going on is it's multiple choice or fill in the blank or something like that. So I'm going to write it out, and we'll talk about it as we go. If epsilon, so this is 3, this is epsilon. I know, it's kind of weird. It's like an E, but it's like this, okay? So there's epsilon. It's a Greek letter, epsilon. Is greater than 0, so if epsilon is greater than 0, then I got 1 over the square root of x is less than epsilon. Thus, I have the square root of x is more than 1 over epsilon, and thus x is greater than 1 over epsilon squared. Okay, so this is what's going on is we're doing the exact same procedure that I did a second ago. Move them over, square both sides. Okay, cool. Let capital N, that's a capital N, equal 1 over epsilon squared. Then I have x is greater than n, thus x is greater than 1 over e. I'm sorry, I say e because I say epsilon squared. Thus, we have the absolute value of 1 over the square root of x minus 0 is equal to 1 over the square root of x is less than epsilon. So, the limit as x goes to infinity of 1 over the square root of x is equal to 0. Okay, what? Oh, I just had to pause for a second because this is just crazy. We got rid of our Calculus 1 sections that involve epsilon delta proofs of limits. You didn't see me do a video because it ain't on your homework anymore. This might be just a leftover. I'm not exactly sure. But it is interesting. And if you go and look up the epsilon, the delta epsilon, epsilon delta method of proving limits and stuff, cool. Do that on your own time. Wikipedia is your friend. This is kind of what we're going through here. And I'm not going to go any further because it's not really worth it. Here you go. Next question. Last question. 26022. And we got the limit as x goes to infinity of 6 cosine of x. Okay. Now, I'm going to go ahead and tell you that the answer is DNE. Huh? Denied. No, I meant, what does it? Oh, what does DNE stand for? Doesn't have an answer, right? Brain fart. Anyways, moving on. Undefined. It's undefined. That's basically what it is. It's undefined. Okay, cool. I always just say denied. Anyways, that's fine. So why is this answer gonna be that way? What's going on with this problem? So we got a cosine graph that does this. That is not what I was trying to do. There you go. That's a little bit better. And I'm going to ask you, as we go towards infinity, what is the single one answer, as in y value, what's the single one y value that this will actually end up being? Now, I know that it's hovering around 0, but it's never going to be just 0 because it keeps on fluctuating. It never hones in to a single point. And therefore, your answer is basically, there is nothing there. There is no limit as it goes to infinity. So, undefined, DNE. That's it. You're done. Okay, that's all I got. Thank you very much, and have a great day.